When I was a first-year student going into the Faculty of Science, I think that I was pretty lost, to be honest, because I didn't know what I wanted to do with that. So I thought it'd be a good idea to kind of get some hands-on experience and find out if I actually liked doing work in the field that I had chosen to study. So I did some research on the different professors. I saw what they were doing. I went and visited a few labs, including Greg's, and I think that's the great thing about so many professors in the Faculty of Science is they're very open to you coming and actually seeing firsthand what they do. I would say I was motivated by a desire to learn more about chemistry as in terms of research and what I like to do as a scientist, and I was motivated by a desire to get some hands-on experience that I could take with me in my career. Our work is entitled Estimating Dietary Exposure to Polycyclic Aromatic Compounds from Food-Grade Plastics, or PACs for short, are a class of chemical that our lab COGRAD, or the Center for Oil and Gas Research and Development, routinely studies. PACs are widely studied in the literature because they're considered to be persistent in the environment, meaning they remain around for a long time and they're hard to get rid of. PACs are naturally found in fossil fuels such as coal and petroleum, and they have found to be toxic to both humans and animals. And particularly in this work, we kind of looked at the cancer risk that PACs have been known to show to humans. These PACs we are looking at are in your food plastic containers that you use. And there have been other studies in the literature that have shown that these chemical additives can migrate from your food plastic into your food. And so based on these studies, we hypothesized that these petrochemicals could do the same thing. And then the US Food and Drug Administration has a list of guidelines for measuring the migration of these chemicals called food contact chemicals from your plastics into your food. So we were able to use that. Environmental chemistry often has a lot of ties to human health. So these PACs have been shown to cause problems to the environment, and they've been shown to be detrimental to humans as well, just the suspected carcinogen being one of those problems. And I think as consumers, we have a lot of power, more power than we think. If you continue to buy these food storage containers, you continue to support companies that are allowing these chemicals to be released into the environment, and then you're putting that in your own body. So I really hope that this work will kind of inspire people to switch to alternatives that are maybe a little more environmentally friendly, such as glass storage containers. But I think what really makes our work novel is, one, this was a very comprehensive study. Our lab is capable of looking at a very wide amount of these compounds, and to estimate that dietary intake, I think, was really interesting. And then something else that I'd really like to point out is these compounds are also produced through the incomplete combustion of fossil fuels and organic matter. So when we have these big forest fires and we inhale the air, that's a possible source of exposure to these compounds. So I think that this study, our team was really able to identify a novel exposure route that hasn't been considered yet. I think for me, the biggest challenge of doing research in the lab is the learning curve. I think you could spend an entire year in the lab and you wouldn't even come close to learning everything that there is to know and all the things that there is to offer in the lab. And I think that learning how to do these things and doing them properly and to actually understand what you're doing takes way longer than days. Sometimes you really have to trudge through that learning because you're dealing with technicalities and really small things. For example, this summer I learned how to clean the ion source on a mass spectrometer, which is a really delicate piece of an instrument we use. And in the moment, it doesn't exactly feel like groundbreaking research. And I think to overcome it is to just understand that those little technicalities and those learning moments are ultimately what make you a better scientist in the end. You can't have the papers and the fun and rewards without learning these little things and these little technicalities. Another way to overcome it is to take pride in learning from those around you. And then in terms of the lesson I learned, it's really cliche, but just embrace the journey. A lot of chemistry and science in general is all that we don't know and all that there's left to discover. That's like half the point. And instead of letting that make you feel uncomfortable, you can let that challenge you to learn those little skills and learn those technicalities, because that's ultimately where you're gonna see the reward. The highlight of working with Greg and his lab has been the people. It has truly been such a gift to work with such smart, kind, and like-minded people. I learn so much lessons from all of them and they inspire me every day. I think Greg has worked really hard to create a place where you feel valued, your ideas are valued, and I'm just so lucky to have like a place on campus where I feel so safe and I feel welcome.